Today you'll be learning Chapter 4.2 and 4.3, Experiments and Inference for Experiments. Words to know. Observational study. Observes individuals and measures variables of interest, but doesn't attempt to influence the responses. Experiment. Deliberately imposes some treatment on individuals to measure their responses. Lurking variable. A variable that is not explanatory nor response, but still may have influenced the response variable. Confounding, a situation in which the effects of two variables on a response variable cannot be distinguished or separated from each other. Treatment, a specific condition applied to the individuals in an experiment. Experimental units, the smallest collection of individuals to which treatments are applied. Subjects, human experimental units. Random assignments, experimental units are assigned to treatments at random. Completely randomized experiment, treatments are assigned to all of the experimental units by chance. Placebo effect, some subjects responding to an inactive treatment. Double blind, neither the subjects nor researchers know which treatment a subject receives. Single blind, either the subjects or the researchers know which treatment a subject receives. Statistically significant, an observed effect so large that it would rarely occur by chance. Let's do some examples. Example 1, observational study versus experiment. A University of Helsinki study wanted to determine if chocolate consumption during pregnancy had an effect on infant temperament at age 6 months. Researchers began by asking 305 healthy pregnant women to report their chocolate consumption. 6 months after birth, the researchers asked mothers to rate their infant's temperament, including smiling, laughter, and fear. The babies born to women who had been eating chocolate daily during pregnancy were found to be more active and positively reactive, a measure that the investigators said encompassed traits like smiling and laughter. Here are the questions. A. Was this an observational study or an experiment? Justify your answer. B. What are the explanatory response variables? And C. Does the study show that eating chocolate regularly during pregnancy help produce infants with good temperament? Explain. We will go over the answers at the end of this video. Example number 2, a completely randomized design. Many utility companies have introduced programs to encourage energy conservation among their customers. An electric company considers placing small digital displays in households to show current electricity use and what the cost would be if this use continued for a month. Will the displays reduce electricity use? One cheaper approach is to give customers a chart and information about monitoring their electricity use from their outside meter. Would this method work almost as well? The company decides to conduct an experiment to compare these two approaches with a control group of customers who receive information about energy consumption but no help in monitoring electricity use. The questions. Problem. Outline a completely randomized design involving 60 single-family residents in the same city who are willing to participate in such an experiment. Write a few sentences how you would describe your implement design. Now let's check your answers. The answers to example 1, observational study versus experiment, check. Question A was this an observational study or an experiment? A. Observational study, because there was no treatment in the on the pregnant woman. B. What are the explanatory and response variables? The explanatory variables were the mother's chocolate consumption, and the response variable was the baby's temperament. And C. Does this study show that eating chocolate regularly during pregnancy help produce infants with good temperament? Explain. No, it's an observational study, which means there are no cause and effect. And example 2. Let's go back to the problem. Outline a completely randomized design involving 60 single-family residents in the same city who are willing to participate in such an experiment. Let's check the answers. We start off with 60 single-family residents. We split them into 3 groups of 20 for chart information, display, and no help in monitoring. And then with all the results from these 3, you compare the data. And that is how you design a completely randomized design. Thank you for watching, and I hope this has helped. Have a nice day.